Hello, this video is going to be me going through the game I made for Ludum 50, looking over the Unity project at the scenes and assets I created and the code I wrote, and just sort of explaining some of the decisions made and the way things were set up, and particularly the things that were set up in ways that I would prefer not to do on other projects. Fair amount of jank. I'm going to start off with something that's going to come up later in the video otherwise, which is that if you look at the scenes I have set up in this game, there is no level 2. And the reason for that is because when I was working on it, I was getting ready to make level 2, and I think I made a scene called level 2, and then later decided, oh, I'm going to set that up as the final scene, so I renamed it to level final. But when I then went to make a new level 2 scene by copying level 1 and opened that scene, it was a copy of what was in level final. And I think because I had already had a scene that was called level 2, something was getting cached that wasn't meant to be. Or something along those lines. And so I think what fixed it was just closing and reopening Unity at some point. But at the time, I was pressed for time, obviously. And so I just sort of said, I'm going to just ignore this in the simplest way possible, which is to just not have a level named that. So that's every time someone asks me how many levels are in the game, I get very confused because I have to remember we go up to level 5, but there's an extra level that's not really a level. And also there's no level 2. So I have no idea how many levels this game has. Anyway, so like stuff like that it comes up on game jams and can sometimes lead to stuff that gets hard to explain to somebody who looks over what you've done. So I'm here to explain it myself. So I think I'll just start going through the scene. So what I started working through was, as I figured out what I wanted to do, I just sort of implemented things one after another as I was sure they were going to be used. So the very first thing I had was the physics ball, which is here. It's called roller. It's become more complicated than I originally made it, but originally it was this roller script. I mean, really, it was first there was like a Unity example asset that's just sort of this 3D ball that you control, and I eventually just took the code from that and broke it apart into the parts I actually needed, and then got rid of the original. So there's a little bit of code that still looks very much like code that I didn't write that's still in there, but it's from an example asset, so I assume it's fair game. So there's a very complicated object to start from actually, but we'll get right into it. So right now everything's disabled because at the beginning of the level you can't see your character. The main actual ball itself, which controls all the physics, has the various Unity components to give it a sphere's shape and visuals. And I've disabled the renderer that would be on this object. So there's nothing drawing the sphere anymore. That is because, as a child to this, we have the model of the imp, which is also disabled right now. But if I enable it, you can see there it is. Let me turn off. That says here. And this that just has its own renderer, and then a little script here in physics that makes it rotate, or actually this one just makes it get bigger, because the only reason it rotates is because it's childed to this other component which does roll, like the sphere does roll naturally, and that actually necessitates these other objects down here. So the camera is placed in the scene, behind the controller, but if we didn't do anything special, I can show you right now, if I rotate this object, then the cameras are way over here. So they would be pointing down like this at the scene. So to get around that, there are a bunch of scripts on these that prevent that from happening, more or less. There's one script here. There's a lot of this happening where I needed to control rotation on 2 axes, and rather than doing a bunch of complicated math, I just had one child control the horizontal rotation, and then another object control the up and down rotation. So essentially one object responds to inputs and does this, and then an object that is a child of that responds to input and does this. Because I think otherwise, if you rotate this object and then rotate this object, it's hard to see. Well, here, if I this is better. If I rotate this object, you can see that these axes change. So if I'm changing on the red axis, it then changes where the blue axis is, and you get really out of whack very fast. If you know rotation math in games, it's terrible. There's a reason there's a whole part of the Unity game docs that talks about quaternions and says, don't touch these if you don't know what you're doing, because it's bad. So a lot of hacks like that, where that's not efficient. I would prefer not to do it that way. It's probably the simplest way to get it working, but I would just rather solve the math on another project, but if it works, it works. So the specific scripts aren't super important. I'm going to go through those in more detail later. Roller controller, which is a great name, if I can claim that myself, has a bunch of important variables on it. These control things like how fast we move. These ones are the ones that are just directly from the original sphere controller that Unity provides. These are used for triggering certain music tracks and sound effects. And then these control the power of the explosion. And these change as you pick up power-ups. The power-ups themselves have their own script on them. Let's see if I can grab one of those. Here's one of the power-ups. You can see that it's got just a mesh renderer and then the collectible script, which is itself controls what it changes when it is collected by the player, in addition to the growth. So these are all affecting the explosion. I think this one is actually says how far away you have to be to collect it, and then this one changes how much bigger the imp gets. After this roller controller script handles all that stuff, then you have the following scripts, which just sort of have objects in the scene rotating according to player input. There are two cameras. One of them draws everything in the scene except for the player, things that are attached as a player on the mask. And this one has this camera blitz script attached to it, which basically applies a shader, and that's where we get all the dithering and edge drawing from. And then the other one just draws the player. It is the exact opposite. It only draws that, and it draws everything on top of that without the shader impacting it. So that's why when you're playing the game, only the imp and I think the power-ups are not dithered or have edges around them in that way. In addition, there are also the explosion and smoke particle systems, which are also disabled by default. I think you can get those running in here. You can see this is just this just runs once the explosion happens, and all they are is this. I don't know if there's a way to zoom in easily and see it, but this will work. Yeah, I'm just spawning in a bunch of spheres and a bunch of lights on this one, and then this one is just spawning a bunch of transparent spheres as well. And this is straight from a tutorial I found on YouTube that just said, like, do this, and I sort of tweaked what they said and took their advice and worked from there. So I'm relatively happy with it. It looks so much better than it would otherwise because of the shader. The dithering effect like limits the color palette, and so when the explosion happens, it looks really like stark. You can kind of see it's not as great here. It's just sort of this beam, but with the with this on, you can see it really, like, it looks really blown out, and I like how that looks. While we're talking about the player, we might as well show the 3D model of the imp that I made. This is the finished thing. Well, this is the finished thing. I use a texture painter, which is, very easy for just literally scribbling on a 3D model. That's what I did. The actual model itself is sort of a horrible amalgamation. You can see its topology is nonsense. This is because it's the product of just merging a bunch of unrelated shapes together. If I disable this and enable all of these, you can see it's just a bunch of spheres and Bezier curves that have been flushed out. This is crude, crass, even. It looks a lot better when things merge and there's not this horrible crease between the buttocks and the rest of the body. That was an important thing to get rid of as I did the merging. So you can see now it's just, it's just there, and you can barely even see it because it's all black anyway. It's really just the reflection it adds, which I think is really funny. I won't apologize for that, but it's certainly a little juvenile. I basically just used the Boolean tool a bunch of times to merge everything together, and then I think I did some sort of mesh decimation or whatever it is to get that done. 3D modeling is not my forte. I do it out of necessity at times, but I'm sure there was a nice, comfortable, sane way to make something like this and not end up with all these horrible triangles. But this is what we have. It's worth going over the code on some of the things I just mentioned, I think. So this is the roller controller. This is one of the larger scripts in the game. This sort of controls the player as well as a couple of other semi-related things. It's using this sort of the structure that's not quite singleton. It doesn't really stop there for me multiple, but there's a static instance of the class roller controller that is available to any other script. So and as the scene starts up, this roller controller, of which there should only be one in the scene of, just grabs itself and says, hey, I am the instance. For all questions related to the instance, please ask me. So we can do a lot of important things with that. It also just sort of grabs all of its components that it needs. This is the camera, and it only needs the one camera because they both have the same position, and it's used just to make sure that the controls are relative to that camera. So it kind of just grabs one of the two, but that still works fine. And then rigid body audio source, we set the volume to be the menu's volume. That's another script, of course. And then we set up the cursor to work as expected, and then the game mode is sort of the where in the scene we are. At the beginning, you've got the introductory cutscene, then the gameplay, then the explosion, and then the outro cutscene. And those are sort of 4 modes attached to this enum that is described up here that we use to control some stuff. And this is mentioned in this script, and then another one, which is sort of the other main managing script. All these other variables, these are things that are mentioned in the inspector, I think as shown. These ones are sort of from that original script I mentioned, the original sphere controller that I cribbed from, as well as this, I guess. Everything else is, I think, mine, or these two. But in the update, we've split off to, if we're doing gameplay, this is sort of the main mode of this script. We're doing a bunch of different things. This is a hack, man. So on the very last scene where you're just sort of exploring the town post game, you're not actually allowed to explode, and it's got that message that says the end. The timer that eventually has you explode in that scene is not disabled. It's just set to 999999999. You're not ever supposed to get that number up more than half a minute or a minute in normal gameplay. And so we basically are able to just say that we know we're in that scene if the timer is extraordinarily high. And so the way that I have this message playing of, hey, it's the end of the game or whatever, this text pop-up thing we'll describe later, but essentially we're sending that message over and over again because we know if the timer is high, then we must be in that last scene. And that's used for a couple other things as well, some sort of more modal input. That's also what I think what disables you from hitting the explode button early. But anyway, we're grabbing the player's input from the WASD keys. If I had more time, was smarter, I would have set it to be more flexible, so you could input different things. I know other keyboards don't use WASD, or I would have let people use the arrow keys. That would have been the smartest thing of all, but this is what I did in the time I had. And we get jump input. Move is modified several times. First, we're just getting it scaled by the camera's position. So, like, if we're holding straight W, we don't want it to be, like, y is equal to 1 in world space. We want it to be y is equal to 1 in camera space, basically. So first we have to get the camera's direction also with the its actual y flattened. It's weird. So for this vector 2, y is representing forward. Really, it should be z if it was a vector 3. In world space, vector 3 is up, and so we want to say ignore that part of the vector, but then get the normal otherwise and just push that forward. Then that move vector itself is modified by the velocity, and this is me grabbing the perpendicular angle, or this is a hacky way of doing this, man. I know there's probably a function for it, but I know this is a way that works, and I worked from there, and I believe I typed this in the other way first because I can never remember which is left and which is right, and then had to flip the minus signs or whatever. If you're familiar with this code at all, this is just grabbing the vector that's perpendicular to this original vector. Then we grab plane velocity. I'm trying to remember what this all is now. I think there was an issue where the rigid body was maintaining too much momentum, and I'm sure there were settings I could have checked to mess with this. But essentially, I just wanted to sort of have the velocity of the rigid body kind of push back. Basically, originally it was just going to be that if you weren't pressing any buttons, the sphere would sort of break. It would sort of push back in the direction it had momentum, and then I just decided to have that enabled at all times. That ended up being better. So basically, the moved vector is then modified by whichever direction the rigid body has velocity in, and then we sort of multiply that by how strongly it's in. This is some math stuff. The dot product here we're getting gives us sort of this will be 1 if the momentum of the ball is the same direction we're pushing in which case we don't want to add it on. We don't want you to just move twice as fast. We only really want this to be applied if they're in opposite directions. So you can see here that by doing 1 minus the dot product, this is at its minimum, or sorry, no, it's maximum, right? So this is going to be a 2 when we're going the exact opposite direction, and a 0 when we're going the exact same direction. And then that is done when we do math min with the magnitude of the movement itself. I think because if we don't have very much momentum, we don't apply a super ton of force, so we just ignore it if the magnitude is low, essentially, and then multiply that by the velocity that the rigid body is moving in. Yeah, that's complicated. That's some weird, dumb math stuff. I don't recommend having code like this around without having a bunch of comments around it or something, or just figure out some functions you can write to make it more clear what's happening. But I was trying really fast to make the physics more fun, and so this is what we ended up with. Boost is something that never got implemented. I tried to have boost pads, and then they were hard to do to make fun with the rest of the game, so that doesn't exist anymore. Then we are setting the timer negative here to have you count down. And then here is yes. We say if the timer's out, or if we're below 1000, meaning we're not in that final scene, and the player is pressing down the mouse button, we explode. And what that means is move to the explosion game state. This is weird. There was a bug where when I was changing the rigid body on the player to be kinematic, basically meaning freezing it, it would complain because I wanted it to be in continuous mode, and a rigid body could not be in continuous mode while it was kinematic, and so I had to do this just to get it to shut up. I don't know if that warning would have ever made anything go wrong, but just to be sure, I just said, okay, for this mode, then it's discrete. We said to be in the case is kinematic, and then we grab all the cameras attached to this and disable them, which puts us back to using the cutscene camera, the one that's really zoomed out, or wherever it is in the scene. And there's a bunch of code for that one. That's a big other script. And then we disable the audio listener because we're only allowed to be one of those active in the scene as well. That's basically controlling what picks up audio if audio is 3D. I don't think we ever used any 3D audio, but if we ever needed to say how loud should this be proportional to how close it is to the camera, we can only have one of those active in the scene. All that happens only if we're in gameplay. If we're in the explosion state, then we basically wait to explode, because you can still see the character until they blow up. And so we have an explode timer that I think is set somewhere. Where is this coming from, actually? No, it's just set to 1. Maybe it just starts out at 1. That's all it is. I know that this is also used by the other script, the game cutscene controller script, which we'll get to later. So I wasn't sure about that. But that just goes down by the time, delta time. This is just the amount of time in seconds that have passed since the last frame, essentially. And then once we hit 0, we stop playing the music for the game. We play the explosion sound effect. We disable all renderers attached to this that are mesh renderers, which means the imp, basically. We do debris.explode, which is a static method on all of the debris objects in the scene, which basically tells all of them, hey, we've exploded, apply forces to yourself as dictated by the variables of this object, which is sort of backwards, but that is how that works. We'll look at that in a minute. And then we just enable all the particle systems in the scene. And we set them to be larger the larger the power of the explosion is, which makes it so bigger explosions look bigger. That's basically all that is. Begin gameplay is a script we call statically from another script when we move out of the intro cutscene. And this just sets the mode, make sure that if there's any sort of blackout enabled, it's just disabled. Disables the demo imp, which is a special imp that's in the scene, which is the one that floats in that first intro cutscene that's never shows up again. If that's somehow still enabled, we get rid of it. We enable the mesh renderers on this, which is just the imp itself. And then we sort of undo the opposite of what we showed before, which is to say that start the gameplay music, change the detection mode to continuous, and make ourselves non-kinematic and play the audio. Playing outro music is similarly done off the same audio source. We just put the outro music into the audio source and play it. And then in fixed update is where we actually do the physics code using the sort of input direction we have from above. And so this is very directly just from that one script I mentioned. It's just applying momentum to the physics body, but I figured why mess with it if it works already. And I know this we never used torque, but that was much harder, just sort of not fun to control. So this might as well not even be here. So we're just directly adding force to the rigid body, raycasting down to see if we are near enough to the ground to handle jumps. And I did add this. So I needed to change the default gravity of Unity, because for whatever reason, I'm sure it's an issue of like scale or something, but exploding with the normal gravity looked really floaty. Like cubes would not get knocked up into the air and just sort of dangle and sort of tap down lightly. So I ended up tripling the basic gravity. So instead of being 9.81, it's like 30. And that was great, except that then when I tried to go up a ramp, the sphere was too heavy to go up the ramp because there was so much gravity. So I have it set that, hey, if we're grounded, disable like a ton of gravity. Basically, we're applying a force in the opposite direction times 20. So we're restoring original gravity almost. It's, gravity equal to 10. And so it's a very hacky thing to get it so that we can go up ramps easily, but that the sphere itself is not super floaty when it's in the air. So once we jump up, we sort of are hit by the normal amount of gravity, and that feels appropriate. But yeah, that's the only thing I added. The jump here is just if we're using the jump button and we are close enough to the ground that we consider it valid, we just add impulse power to the thing, and then we disable that jump input. Collect is a script that is called elsewhere when we get close enough to one of the collectibles, and it just takes all the information from that collectible and applies it. We enlarge our imp, which is another script I'll show later. We push the camera slightly back from the player to give more space, and that sort of further emphasizes that we're getting larger. That's something that like Katamari Damacy does, obviously. Then we play the pickup sound effect. And then again, this was not ever enabled, but this is what boost pads would have used to boost the player. Let's look now at a couple other things that are attached to the main character. Roller follow just, if we're in gameplay mode, sort of changes the angle of this is the X angle. So I think this rotates like left to right as it moves with the mouse X. So as I move the mouse left to right, it pivots that one object and the cameras then follow. Because it sets its rotation like flatly, not other than like its local rotation or something, this is what prevents it from like rotating as the sphere rotates. So it mirrors the position of the character, but not the rotation. That's the important part. I think below that we have which one of these is it? On the script below that we have the controller camera, which is a little bit more complicated thing, which is slightly more complicated. It grabs the audio listener and cameras attached to it, depending on which is which. So I believe basically this one says, hey, if we're in gameplay mode, pivot around the y-axis, but with this limited range, so we can only look so down or up, so we can't go all the way around. as well as making sure the audio listener is enabled in the scene, and otherwise disabling them. This might be redundant with some code that I wrote in the other script, actually, I'm not sure now. But basically this does the same thing as the other one, it's just slightly more involved. Because it also slightly gives some input to the cameras. On the debris script, you can see some basic code here that just handles what I said. The main one is if we explode, we just grab all the debris that have been registered to this list of debris in the scene, which are being registered automatically. In start, we just sort of grab ourselves and say, hey, I'm one of the debris, put me in the script. And to get rid of themselves when they're destroyed. So all we're doing is adding the explosion force on explosion from the point of the player. And then in update, all we're saying is if we're in the outro scene, so the explosion is over, we should reset ourselves to be kinematic, because essentially we don't want anything toppling around while things are being talked about. We don't want to see, like, you know, the game go to like, oh, Mr. Wizard's fine, and then as we move to that, like, something falls and smacks it out of the way, or even before we get to that part and have it be very like, something's gone wrong. So it freezes all at that point. The collectibles, pretty much as I described. Here we have some very strange rotation code that I wrote very sloppily just to get it to do that sort of weird pivoting, and I kind of wrote some stuff thinking like maybe this will work, and then it looked okay, and I left it. And then here is just we say, hey, if we're close enough to the player, then we collect ourselves, do a text pop-up, and then destroy ourselves. Let's talk about text pop-up now, actually. That is a script that is fairly involved looking, but basically it's just a UI object that, again, does the sort of singleton thing I described, where it knows in the scene where the one copy of itself is, and then as it receives these static pop-up inputs, it sets its variables appropriately and sets a timer, and then this just handles that timer so that the opacity of the text fades out over time in a pleasing way. Nothing really more complicated than that, but it's a lot of code and had to test to get it working. The imp physics script is a little complicated because it handles both the imp that rolls around in the scene as well as the demo imp, which I described. So this is sort of a double singleton. And let's go actually show that demo imp. So I believe it's just sort of in the scene somewhere. Search by, oops, the script's in the scene. These are the two that have it. The demo imp, yeah, it is here on this whole camera stack, and it's also disabled, but it's just this big imp, and it moves itself to be in the appropriate spot, and you can see that it says, hey, I am the demo imp, so do not treat me like the other imp in the scene, as the opposite imp does exactly the opposite. So this really should have been two scripts basically, but there were some changes that I made while I was working on it. The demo imp sort of does this one thing, and then the non-demo imp does an entirely unrelated thing. It's just sort of, I wonder why these two scripts follow the same code. But yeah, so there are two instances in each scene. They're sort of both set the same way those instances before were mentioned. But basically the demo imp rotates in the scene. That's all it really does, but only during the intro step. And then I think, yes, I had some code that was going to be set up so that the imp sort of tried to write itself as it was moving around the scene. You stopped rolling, it would sort of slowly lerp up to be standing up, or slurp, spherical linear interpolation, if you don't know what slurp means in this context. So it would sort of try to stand itself upright without any other effect from the thing it was parented to. But that ended up looking kind of that ended up looking kind of bad, so I ended up instead getting rid of that, and then later I realized that as it was getting bigger, it was sinking into the ground, so I changed it to move itself up out of the ground the larger it got, so it would stay sort of centered, but still above ground. Other than this, there's just these, enable demo, disable demo, and enlarge functions that are being used. They do what it says on the tin, basically. So let's look at the rest of the scene now. I'm going to just move through some basic stuff. These are the characters in the scene. They are set up really stupidly. They are essentially a cube that's been scaled that has two children objects, which is the texture on the front and the back, as their own plane. As their own planes. There's really no reason to do it this way. You would normally just, I'm sure there's some better way to do this, but I was in a hurry and I was like, well, this will work. Each one of these just has these two drawings that I did very, very hastily on each one, and I've put them in the scene randomly. They are not said to be kinematic, unlike most other debris in the scene, so they can be knocked around while you're in the middle of gameplay, which is an important feature. I very much enjoy being able to jump up and hit these. Whereas everything else, like all of these pillars or whatever, they are said to be kinematic, which basically means they're frozen. No amount of speed or size will let you actually bump into these. Though that is worth noting, the ball you are controlling never gets any larger. It's only the visual imp that gets larger. There's no actual Katamari thing going on where you get larger and can knock over stuff. That's really not what's going on in the game. It's just sort of to indicate that your explosion is going to be more powerful, and because it's funny. But this is essentially what's going on. I'm going to delete things as I talk about them so I don't get confused. Let's get rid of all the characters in the scene. We can see I have done some small amount of organizational stuff outside of stuff like this above for the gameplay. In the level scene, you can see this is all just on one big plane. We have static geometry, which used to have these 4 things enabled, which were just sort of, will we be able to see them? Oh, they might be really small now. What happened to these? Oh, their mesh renderers are disabled, so they're enabled but not in the scene. Yeah, so just these sort of bounding boxes on things, just to keep things contained. That ended up being no fun, and I didn't like that, so I ended up just entirely getting rid of them. At first I was worried about, like, what if the player just, like, wanders off into nothing? They can only do that for, like, 30 seconds, and then they die, so it doesn't really matter. But, yes, this is just all the static things that aren't really debris, they're just colliders. Get rid of those. The dynamic geometry, these are all the things that can get knocked over, essentially. The characters that I deleted earlier should be in here, but I got lazy. One character is here, and that's the wizard. This is the first one I made when I was testing stuff out and figuring things. And he's special because he has a extra script on him besides just the colliders and renderers that all the other ones have, which is topple target. If I open up topple target, you can see that in addition to doing in addition to a debris script on this one basically just handles where this has been. So it starts out by saying, I'm starting from this position, and I'm adding myself to the list of topple targets in the scene. I don't know if that ever gets used, actually. Yes, that never gets used. So it just marks where it is, and then every frame of the scene says, hey, have I moved a significant distance away from where I started? And this is scaled by the local scale of the object. So bigger objects have to move further before they're counted, basically. So you can't just slightly jostle a tower. That was happening before. I bumped the tower slightly, and it was like, oh, this wiggled, you know, one thing away and then settled itself back in, and so it counts. And I said, okay, no, it has to be scaled. And stupid. So toppled is set to this. This is some jank code. It should look like this. It should look like, you know, hey, if we are not already toppled, then set toppled to be equal to all this stuff. And the reason you would do this is because you don't hypothetically want to run this thing every frame if we already know we've been toppled, because it's never set to false. We only care about it being set true the first time. So this would be more efficient because you would not be running this unnecessarily. This would never come up actually for this game. It's a very small computation, basically. We're even avoiding using any like square root stuff by checking the squared magnitude. So really not a huge concern, but terminal optimization brain. So instead, I have both done this thing and then further sort of optimized by it by using short circuiting to do it all in one line. So first we checked if toppled's already true, we don't need to check the second condition. And this is horrible for readability. I don't recommend this. It's very, very, very dumb. At least that's how I feel about it. I would not want to show this to somebody and have them have to guess at what's going on here. It looks very strange, unless you're used to that sort of thing. Beyond that, the only other thing in the scene are the collectibles as far as like interactive game objects go. We already talked about those. They are just this mesh renderer and this collectible script, which just apply these values. Notably for the topple targets, though, this is interesting. There are all these intro and outro points, and slightly different depending on the setup, but these represent places the camera goes and lines of dialogue that are displayed. So for the intro points, it's all the various parts of the cutscene, and so we've got, you know, intro point 0 displays this text, uses these sprites for the two characters. We've got some like zoom or whatever, and the actual position of it in the scene represents like basically a location for the camera to hold. These ones are all faded out, and there's actually this line here. This is a very janky thing where I've just sort of said, you know, hey, if I write some text here, please do a special custom command so that I could set up things like the camera fading in and out for just this one level. But you can see later on where you actually have the camera active, then we have, you know, this is the image being used for this character and this dialogue, and then the camera should be like sitting at this point, holding the same rotation, so I'll be pointing along with the blue axis and looking at the scene roughly from here. And then they're all aligned with their index, so the script I'll show you in a minute just goes and grabs, you know, 0.0, 0.1, 0.2, 0.3, all the way up through all these. It's very tedious to set up. It wasn't a great system, but it worked. And then the outro points represent the things that we are shown at the end, whether they've been destroyed or not, so the topple targets. For example, this outro point 1 is for the grand stage, and it says, you know, instead this one says to focus the camera here, and then allow it to be zoomed out by 25 units, which is pretty far. This is index 1, so this is the second one we look at, it's 0 indexed. This is the topple target we care about, and I have the feature that you can make it care about multiple topple targets, because basically it displays one of these lines of texts based on whether the topple targets have all been toppled or not. I don't think I ever use this. I think it's always just the one target, but I could have said, like, you know, I could have made it, you know, care about this and also all 4 support beams being toppled or something. The other one in this scene is this one on the character. It has its own outro point. Because it's childed to this, it will actually follow this character. If this gets knocked way far away or something, if the character gets knocked really far away, the topple target will, or the outro point will still be focused on it. So it won't be looking at where the wizard was. It'll be looking at where it is now. This one doesn't work that way. If the stage moves somewhere else, this will stay here, and that's because I don't want it to follow like one particular part of this. It's only really cares about this square, but it should really care if the whole thing gets toppled. Like this, if we just know that if this one gets toppled, we consider that like a win. But it just sort of points at where this used to be, essentially. So those scripts are all really simple, basically. I think they're just holding values, essentially. I don't really know what this one does. Yeah, this one just the intro point, and I think the outro point as well. Both just sort of grab themselves and say, hey, make sure that this other script knows about me. And this script is very important. This is the cutscene camera. We'll go back and look at that in a second. This toppled script just, or the outro point just has a toppled property that grabs all the toppled targets it knows about and checks all their states. So the last thing in the scene to care about is the cutscene camera. And this is another large object. Similar to the player, we have sort of this main point that's being aimed at with the cutscene circle script. The second one that's being used, which has the main script on it for all the cutscene camera stuff. Then we have the actual cameras, again, one of which has the camera blit script in it, which uses the shader. The other one does not, and only shows the player. And then this player is holding that demo imp object we talked about before, which it then rotates using scripts that are on these. So a couple of things going on there. Cutscene circle is the very simple version that just says, hey, so the script places the object at a specific location if we're in the explosion mode, basically at the position of the player, but at the floor. So if the player's up in the air, we don't match that. And then if we were specifically in either explosion mode or the outro, so we may or may not be locked to the player, but we do want to let the rotation of this object change as the player moves their mouse to the left through this code. So this just handles that rotation on that axis. And then I believe this other script, cutscene camera, is another long one, but broadly it handles the up and down movement, as well as moving the camera over certain modes. So you can see this has different sprites for the different. We have one. These are the sprites for God that show when you do or do not topple something, and these are the sprites at the end that show up whether you have like knocked everything over or not and beaten the level. This string keeps track of what the next scene to load is. This is the text for the devil when you beat the level or not. And then we have a couple other things here for when the scene is running. Here's the intro and outro points as mentioned in that other one. And then again, this has the instance thing so that we can grab static from other variables or from other scripts. Anyway, so these add themselves. We don't know what in order they're necessarily going to add it in, so we need to do stuff to make sure that this list gets buffered out the right amount. If I suddenly add the 14th index thing before we have anything in the list, I need to be able to make sure there's a 14th index for it to be added to, so we kind of pad it out first. There's probably a function that does this to a list, but I can't remember what it is, so I did this because I know it works. These are some basic things. So the update function is the meat and potatoes of the script. It's just this really long... Oh, and then this thing. But this is basically just split up by what mode we're in and some other variables. So this one is for when we're in explosion mode. Right, this is interesting. If you hit the escape button before you're in explosion mode, so anytime other than when you're exploding, because I don't want people to press the keyboard not knowing how to progress through it and accidentally boot out to the main menu, but this boots you out to the main menu if you press escape at any other time. It's disabled in the editor because in the editor, if I hit escape while the game is playing, that gives me access to the mouse again. It basically turns off the cursor mode. That's like a default Unity thing. And so when I enabled this first without this in it, every time I tried to hit escape to go like debug and like pause the game and like look at stuff that was happening while the game was running, it would boot me out to the main menu. And I'd lose everything I was doing. So I said, hey, I don't need this control specifically while I'm playing it in the editor, but once the game compiles, it gets rid of this, so it's all fine. After this, it actually just goes to the normal thing. So in the intro of the game, this replay bool is set whenever we are restarting the same level in the same scene. So we can say, hey, don't do the intro cutscene again. It just skips over this and goes directly to gameplay. Otherwise, it just sort of moves the camera around to look at whichever intro point we're currently looking at, and then we sort of increment this cutscene index as we go. With some very ornate, or not ornate, but like verbose code, but it doesn't really need to be, but I was in a hurry. So we're moving the camera to the correct position. We are displaying the correct lines of dialogue as necessary, depending on this. Dialogue text is another like static script, like text pop-up that just sort of takes the information that's needed and then draws what it needs to. And then if the player hits the button down, we go to the next line of dialogue unless we're out, in which case then we progress to gameplay. That's basically what's going on here. This run extra is where I'm actually running those extra things that were in the intro points, and this is the only other function that's in the script. It's just, hey, I think we pass in the lowercase versions just to make sure I didn't accidentally capitalize something and break it, but it just looks for which of these matches and then runs the correct things. Fade overlay is another script that just does some UI stuff based on one object in the scene that needs to fade in and out. So this is the black fade that is over everything at the beginning. And then we have the ability to enable and disable the demo imp. But this is all that's happening in the intro. In the actual gameplay, all we're doing is saying that the camera and our audio listener should not be enabled. This is totally inactive. During the explosion, we move the camera to the right position and make sure it's enabled. We give back the ability to sort of, I guess that's pitching the camera. I don't know which term it is. It's not yaw, I don't think, but up and down again, and do some rotation stuff for that. We lower our own explosion timer. This is what was confusing me earlier. I think this has its own explosion timer that it uses. And do we check that one instead, or did we never use this? I don't know. I may have written redundant things. Or no, that's right. This one is not for when the explosion happens. This is for when the explosion can be progressed through by clicking the button. We want to make sure that at least 5 seconds are waited before we move on to the next, like the outro sequence. So this is controlling the control for that, and not for the actual explosion to happen. That's why I was confused. But then once we are down below 0 for this, then if the player clicks the mouse in, we go to the outro thing and we start the outro music, which is something we activate through the roller controller because it has access to the actual audio file. Lastly, if we're in the outro scene, this is a janky thing. I kind of had 2 different modes in here because I realized that before we get to that last one where the demon or whatever is saying like, oh, we beat him or we didn't, that's a different camera position and we want it to be working a certain way. But over here, this is when we're actually looking at like whatever God is looking at. And so this is just a bunch of stuff where we grab the right position, we aim the camera at the right thing, we give it back the controls as normal, and then we display one of 2 lines based on whether or not the thing is toppled. And then if we hit the mouse button, then we move to the next line of dialogue and increase the thing unless we move out of that. Right, yeah, unless we're done, in which case we move into this thing, which is now the last line where we're looking at what the devil has to say about the level, and it's just focused on the center of the stage. We have everything set up as normal again. Sure, just copied the code from the explosion state, I'm pretty sure. And then here we say if we press the button now, we're either going to, if we succeeded, we're either going to the next scene, or if not, we are setting replay to true and restarting the current scene so that we know, hey, we need to do a do-over. So I don't know I think replay is set up such that it's not static, right? So it's not going to accidentally, if I replay the first scene, it's not going to skip it going forward. Or no, it would, but then when this gets called again, it sets itself to false. So I guess it's an interesting quirk of the way that reloading a scene works, where I think like certain start functions aren't called again exactly, or I don't know. That's might be something going on there. I might be wrong about how that works exactly, but it works, I think. So that's nice. Yeah, I think that's all the important stuff for the actual game object scenes, other than the UI stuff. Well, really quick, the camera blit object thing I talked about just sets this this one blit, which just says take the current scene and render it with a specific shader, and that shader is attached to the object or whatever. And then this is set this based on whether we in its settings have allowed dithering or not. Dithering option exists because it makes recording awful, and I was getting some problems with that early on. I wanted the ability for people to turn it off, myself included, if they wanted to record gameplay. But I haven't really had any problems with it since, so oh well. Let's see, other UI stuff. Dialog text, as mentioned, has a bunch of these 2 horrible functions. It just has access to all these different objects. It has the image, the text box for the character, and their text for both characters. We sort of just set up those here by grabbing them all out of the hierarchy. And then on disable, it turns everything off. On enable, it grabs the text and images for both of them, which are null by default, and then activates the correct things and one of the 2, one or both, or either some number of the character images, and this is the opposite depending on who's speaking, basically, because there are 2 different text boxes, one that's left justified, one that's right justified, depending on the speaker. And then display timer is a script that actually is totally autonomous, where it's just grabbing each frame, depending on game mode, information from the roller controller and displaying things. So this is another janky thing where I think, right, yeah, in gameplay we are showing the timer, but I believe, isn't there something here that says if we're on the last scene we don't actually show this? Oh, I think I just removed the object from that last scene. Never mind, that's what it was. There's nothing special custom code here, it just is removed in that scene, my bad. But yeah, so it's disabled unless we're in explosion mode or gameplay mode. in gameplay mode, the click to continue pops up once we are done with the explosion timer, which means we can click to continue because I wanted some indication of how you do that. And then in the gameplay mode, it just says what the timer is and grabs that information from the roller controller timer, which is exposed. Dither button, these are all on the main menu. The fade overlay is another script that just, again, really janky kind of code, but it's got an enum that just says what state it's currently in, and then it accepts information to set the mode. And so based on its mode, it either fades in or fades out, basically setting the opacity of the overlay in each update step. Really basic stuff. So I think that's all of the things that are in the scenes programming-wise. So I can move between them now and see if there's any interesting nuggets going on. So the first scene is the one I set up originally, and so I started with just this sort of main structure, and then I added a ramp and more ramps and things like that, and this overlay. So this was like, it ended up more complicated and more difficult than a lot of the other levels later in the game, which is, my bad. But once I had this all set up, I didn't use prefabs as much as I should have because I was trying to avoid that. The only prefabs I've been seen are like the 3D models and stuff like that, as well as the triangle, which I made in Blender because I couldn't find a default like triangle object in Unity, which I think is correct, but surely there's a better way. I was just like, I don't know. I don't want to figure this out right now. So I made a triangle in Blender really, really fast. But I set this whole scene up, and then it was like, oh, I should, make a different scene that's easier, and I didn't really expect it to be easier, I guess, but this scene ended up being a lot easier because there's no ramps. You just sort of roll around for whatever, and same setup as before. These are the two topple targets. It's always the wizard because I just copied him into every scene. Well, I didn't copy him in. I just literally copied the level 1 and then made changes. So I just deleted a bunch of the geography and or geometry and then put more stuff in. So it was all like that. And I don't know, it just sort of continued from there. I was like, oh, well, this is an idea for a level, this is an idea. I think I mentioned in the other video, I did all this in like 6 hours. Like, it was 2 or 3, I think it was 3 p.m. the last day with the 9 p.m. submission date. And I was like, I need to add more than one level, because so much of it was just making sure this level worked and that the final level worked, because this scene has some weird stuff going on in it too, to make sure it works correctly. Like I mentioned, it's, the player is set to have a timer of 999 right at the beginning. Oh yeah, it's in scientific notation, but a very big number. And then stuff like certain UI elements are disabled as well, etc. So, oh yeah, and for the gameplay music to switch to the other one, I just changed what's in here, which was pretty easy to do. I don't think the other levels really have anything interesting going on so much. This ramp is a joke. You can't obviously go off the ramp. I wish speeded and more interesting. Like I've seen like marble games where you really roll around fast, and that just wasn't. I wasn't able to get that sort of working in a way I found satisfying in this without it becoming really difficult. And so this ramp is more just like an encouragement that, hey, you don't want to explode at the top of this temple, you should go down. And I think it baits players into doing that, but you don't get the nice satisfaction of like, whee, you just kind of fall down and are like, oh, okay. But it's a clear indicator. It's like a level design version of like an exit door of like, hey, you should go this way. Level 5 is similarly just, here's some gameplay. These are really fast to set up. I just wish I'd spent more time on them and had more stuff to do. I think, yeah, not the thing I focused on the most, essentially. So, oh well. The only thing else to describe scene-wise is the main menu, which is hard to see, and this really shouldn't be in 3D mode. You can see in the game preview. It's just this object, and normally I would code things so that rather than going to a whole different scene, pressing these buttons would load up different UI elements, but I figured that's error-prone, and so I just had you go to these separate scenes that have the until set up correctly. Here's the credits if you didn't check them out when you were playing the game. That's how I set them up, and they're just this one script, and this there's just the one menu script that holds all of this information. I think it's just on the main canvas. Yeah. So it's just a bunch of static functions saying, hey, start button says go to level 1, options says go to options, etc., etc. And I think that's all just applied through the, whatever the system's called, the one where just the on-click event stuff. So just grab menu on back button and run that when this is pressed. There is the volume slider, which is a little more complicated because I thought I had to do something more complex here. No, I guess it just grabs the slider and sets the volume. Never mind. That's a really simple script. You just grab the volume slider and set menu volume to be equal to that, and then set all audio sources to that when they get initiated in each scene, instantiated. So, very simple script. I think that's all the scripts, actually. We've made it. Dithers button is literally just display the text dithering or not dithering based on whether it's enabled or not. Actually, it doesn't even check itself. It just checks the menu dithering because it's already set to set the dithering for the other script. So, very, very simple. I don't think we have any scripts let's talk about other than, the shader. Let's talk about the shader really quick. This is a lot of cobbled together code from examples online and my own knowledge. So basically just some basic functions for the dithering and the edge line drawing, basically. This is our dither table. This is cribbed directly from someone's tutorial. This is a get hue function, because I did something that I thought was interesting where I believe the line detection code was just going off of like literally treating I may even have the code here originally, I can't remember, but because this is some stuff I was like experimenting with, and so I had kept the original around. God, this is ugly to look at, but it was grabbing, you know, the pixels near each other, and then if they were significantly different enough, it was saying, okay, there's an edge here, so let's draw the edge. And so it was just checking difference based on like physical difference, like treating them as vector 3s or whatever. So, you know, the more red, blue, green versus the less blue, red, green, the further they were apart. But I found that like that put a lot of edges on the shading. That there would be a lot of like, hey, you know, this blue goes to a darker blue where the edge of the shadow is, and so there's a line being drawn there, and that does still occasionally happen. But I tried to avoid that by having it only check the hue of the colors difference. So if they have very different values but are still the same color, that's fine. And so we don't draw edges there. And so this is my code for that. Again, totally cribbed from somewhere else. And then I was experimenting with doing rounded edges, so instead of just checking like the pixel to the right or whatever, checking in, you know, the all 8 directions, and these are horrible. It should have used a for loop for this, but I just want to do it very rotely so I could make sure I was debugging it and whatever. So awful stuff. It, you know, grabs all the pixels each time from all the adjacent 8 squares and then, or 8 pixels, and then the dist is storing the best one that we find, or the most difference, and just checking against all of them. And then this code here, you know, applies the dithering effect and the edge weighting and or the edge drawing. And man, yeah, this is what shaders look like when you're in a hurry. So not too proud of this. Proud of it for working and being quick and not being a horribly inefficient shader, just from kind of the load being applied to it, I guess. But man, that's not great code. I think that's it though. I think that's all the scripts there are, other than ones we aren't actually using, like the boost zone. So I think the only thing to discuss is sort of the assets, because we've seen all the scenes too. 3D models, I mentioned the imp, and here's his texture painted thing. Here's R1 triangle, and there's that material. Associated files just has some like stuff I use for logos and things like that. Materials is all the different materials in the game, so we got automatically generating materials for all the different sprites that I used, as well as a couple different ones we're using for various things in the game. These are the explosion pickup things. These are functional ones, and then this one was, I thought I would sort those out, and I never ended up doing that. So the music, all of these songs are me playing on my guitar, which is then fed into a like portable amp thing, which then feeds back into my computer through like a Rocksmith cable, and then was recorded and used mostly just with the effects on the portable amp. I think so you know, all of them except for the main gameplay one are just the guitar. But for the gameplay one, I went to my basement. We have a drum set, and I recorded myself playing drums for like 10 minutes, and then picked out like the most salvageable minute loop and just used that, and then played that back to myself and recorded guitar over it, which turned out okay. And then I recorded myself doing growly vocals and squealing into my microphone, and then that sounded very weird because the drum recording, which I recorded with my phone, which sounded awful, obviously had a lot of reverb on it, and then there was no reverb whatsoever on the digital recording or on my mic, so I had to add a reverb to those manually in the program I was using, and so that ended up being saving that. That would have been much worse otherwise. I mean, it's pretty I won't say bad. I think it does what I want it to do, but it's certainly not like good by certain definitions. And I very much just was like, I'm going to tune my guitar to drop D, and I'm going to hammer on tritones because those sound like the devil, and that's going to make me sound like a real metal guy. I'm very amused by what I ended up with, is what I'll say. Sound effects were just the two. Explosion is me going pop with my mouth into our microphone, and then all the screaming, like the voice here and the scream in the background, you can hear this all one sound. That's just, you know, something I took and then pitch shifted and added reverb to, and this as well as, I think, just pitch shifted. So yeah, both those are pretty simple. And yeah, I think prefabs, should use prefabs more. I don't trust Unity prefabs after bad experiences, but they do mostly work. These are 4 characters. I drew them in a hurry, and I kind of gave them names arbitrarily, just sort of like, here's some people to populate with, because the whole game was about the age of humans after a bit of time, and I was just focused on the level geometry and the mechanics, and that was sort of an important part of the game narratively, and I wanted there to be people around, but man, it was one of the things I did at the last minute and put no time into. Music, levels, and characters were all things I did within those last 6 hours that were very rushed. Yeah, I think textures is just all the things I drew. Oh, never before seen a dummy devil sprite, which is to get something working, and I didn't have anything picked out, so I drew this. I drew these at first, these two, and was like, cool, those will be enough for at least some of the dialogue, and I'll come back and draw the rest of them later. And then I drew these three later, and you can see that they are from a different drawing session because I forgot the correct size to draw them at, and so it looks totally bad. Whoops. Anyway, and then these two I drew for I intentionally de-emphasize his facial expressions. He just says the mouth turn up slightly when he's pleased. You can see I give them important names for me to tell them apart. Oh yeah, and then the text boxes in these scenes are just the most basic possible thing ever, just because I wanted to avoid the default Unity button UI. You can see if I go to this and I give it the whatever the default one is. Pretty sure it's this one. And if I especially go back to white, yeah. If you're familiar with Unity, y'all, this is cringe. If you've seen this a million times before, it's fine. Like, it's very serviceable, but in terms of that level of polish, I mean, I'm equally mad that I left it on Arial. I at least took it to bold in all caps in order to prevent it slightly. But like, I'm so used to seeing default Unity UI that it's sort of one of those like unconscious triggers where it's just like, oh man, I'm playing, like, yeah, I see it. So I wanted to do the bare minimum to get away from that, and I put the effort in on that, but could have done more. But I think that's everything there is to talk about.